Welcome to a lesson on 4.7, which is the quadratic formula, which can be used to solve a quadratic equation. We'll be looking specifically at the formula, and then also just part of the formula known as the discriminant. We want to be able to look at that discriminant as something that tells us whether or not we have solutions for x. Or if we're looking at a graph, we want to be able to look at that discriminant and say, I can use the discriminant to tell me if the graph crosses the x-axis or not. So those would be things that we're going to do. Here we go, quadratic equations. How do I know I have a quadratic equation? Well, there's a degree of 2. What does the degree of 2 mean? It means that the biggest exponent is 2. So when you see degree, again, that is the biggest exponent. Degree means biggest exponent. So when it's 2, we're looking at a quadratic. We've solved quadratics by factoring. We did some completing the square. Completing the square can be quite challenging. The nice thing about completing a square in some of my classes, we actually used it to come up with a quadratic formula here. I'm not going to do that here, but we did do that in some of the classes. And then finally, you could use your graphing calculator to see where does my graph cross the x-axis, and those are also solutions. So, using the quadratic today. Pardon me. There we go. Jumping all over. Okay. I think I got it under control. All right, so here's the quadratic. When you have something in the form, a standard form, ax squared plus bx plus c equals 0, you can use a quadratic equation, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You've been sung that before to Pop Goes the Weasel. And it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. So hopefully you recognize that from years past. We're going to go ahead and just apply that to some problems here. I apologize, the heater's coming on. Hopefully that's not going to take away from our ability to get this lesson done. First step, make it equal 0. We want to make it equal 0 so that I can identify a, which in this case would be 3, b, negative 44, and c, negative 21. Now we just plug in. And this is what I want to see on your test and on your assignments. You're plugging this in. So we're going x equals negative b is 44 plus or minus square root of b squared. Make sure you put b in parentheses. So my b is negative 44. I'm going to go ahead and put negative 44 in parentheses. And then put a square outside the parentheses. Bottom line is, when you square it, you should end up with a positive. If you don't put the square outside in this case, or if you put the negative outside, you won't end up with a positive after you square it. So we've got that, minus 4 times 3 times negative 21. Then put that all over 2 times 3. So that's your setup. That's what I want to see. Okay, so then we want to have you actually calculate the inside of the square root and write that down. Write the 44 down again, and you can go ahead and change the 2 times 3 to 6. But you're going to calculate the inside of the square root. Just plug that in your calculator. That's called the discriminant. And see what result you get from that. Hopefully you recognize that you're going to get a positive, because when I square this, I get a positive, and then over here I have a minus and negative, so it ends up being plus. So I end up with 2188 in here. And we're just going to go ahead and simplify that. 2188, very large number, but turns out that there's only one perfect square that goes into it. That's 4. 4 goes in there 547 times. So it changes to 44 plus or minus 2 root 547, because this would be square root of 4, which is 2 over 6. And the last thing to check to see is if all terms, there's 3 terms, if they all have something in common, if they all have a common factor, and these all do, the 44 and the 2 and the 6 are all divisible by 2. So as they're all divisible by 2, you're going to go ahead and divide them all by 2. 2 divided by 2 is 1. I'm not going to write the 1, but if you want, over 3. Make sure it's an all or nothing. Don't ever divide. You know, like if you had done 44 over 6 is 22/3 and left it at 2 right here, that'd have been bad. That'd have been wrong. It has to be all or nothing. Okay? Over on the right-hand side, a little bit of mess here. I'm going to clear some space for myself. Quadratic, get everything on the same side. So it's x squared plus 4x minus 3. Usually small numbers would be thinking, hey, can I factor this? Worth a look, but I can't multiply to be -3 and add up to 4. So we're either completing the square or now we're doing the quadratic. So x equals -b, -4, plus or minus square root. B squared, 4 squared, minus 4 times a is 1. C is -3. All over 2 times a is still 1. There's our first step. We're going to calculate the discriminant. Just plug that in our calculator. It ended up being 16 plus 12, 28. Get 2 on the bottom. 2 times 1 is 2. Simplify the 28 into 2 root 7, because 4 goes into 28 7 times. And then we can divide everything by 2, so it'd be -2 plus or minus 1 root 7 over 1, but I don't need to put over 1. So there's our answer to that quadratic equation that we got using the quadratic formula. The second part of our lesson is on the discriminant. The discriminant is just the b squared minus 4ac, the inside of the root. And hopefully it makes sense to you that if that happens to be negative, then you don't get real solutions. That's when you're going to get imaginary solutions. But we'll just say there's no real solutions. Or you could say there's 2 imaginary solutions, actually. The graph wouldn't cross the x-axis. So if I had y equals ax squared plus bx plus c, and I went and found b squared minus 4ac, based on that, I know that the graph of that y equals wouldn't cross the x-axis if that b squared minus 4ac is negative. So it could look something like this or something like this. If b squared minus 4ac equals 0, well then you got the square root of 0 on the inside, and that's 0. You end up with one solution. It'd be -b over 2a. Plus or minus doesn't do anything to it because you're adding 0. So you get one real solution, and where is it on the graph? It's on the x-axis at the vertex. It would hit the x-axis once at the vertex. So a sketch of this would look like a graph that opens up, just hitting the x-axis once, or it could open down and just hit the x-axis once. A little bit. Let's see if I get a little better there. Yeah, okay. The idea is we're only hitting the x-axis one time and one time. If b squared minus 4ac is positive, that's when you're going to have the plus or minus something, and it's going to get 2 real solutions, and if you're going to graph that, it'll hit the x-axis twice. So it could look something like this, or it could open down. I don't know where it hits the x-axis, I just know that it's going to hit it once, twice, twice. Another nice thing about the perfect square is if you're not sure something's factorable, you can calculate the discriminant, nothing about the discriminant. if the discriminant is a perfect square, so if you do b squared minus 4ac and you get 4, you know that you could have factored. B squared minus 4ac turns out to be 16, you know you could have factored because 16 is a perfect square. So the basics, just find b squared minus 4ac and tell me how many solutions you have. So for this one right here, b would be -6, a would be 3, c would be -2. Plug it in your calculator or do it by hand like I am right here. I'd get 36 plus 24 is 60. And I don't really care that it's 60. What I care is this is positive. 60 is positive. So how many real solutions do we have? So 2 real solutions. How many times does it cross the x-axis? Twice. 2 real solutions, and it crosses twice. Again, b squared minus 4ac, -9 squared minus 4. A is -2, c is -15. That'd give me 81 minus, because I have 3 negatives basically on the right-hand side, 8 times 15, 120, -39. That's negative. So how many real solutions do we have? None. How many times does it hit the x-axis? It doesn't. There are 2 imaginary solutions, but there are no real. Finally, one more time, bet you can tell what this one's going to end up being. B squared, 12 squared, minus 4 times A is 1, and C is 36, be 144 minus 144. That's 0. When it's 0, there is 1 real solution. And the graph hits the x-axis once. That'd be at the vertex. So there's the basics of discriminant. Discriminant's kind of nice if you want, if you got a word problem, they just want to know, will this ever happen? So rather than do the whole quadratic and figure out when it will happen, you can just do the discriminant and say, yeah, it's going to happen. I know that because the discriminant is positive. And that tells me there'll be solutions. Or, yeah, it's going to happen because the discriminant is 0. And that tells me there's 1 solution. Or, no, it's not going to happen because the discriminant is negative. So that's the basics of quadratic formula and its discriminant. Thanks for watching. Have a great day.